get underway with our fourth rail session on the administrative logistics side. That gives folks a little bit of time to log into their calendar if they're running a bit late with a back-to-back meeting, as is the general run of show today, I think, for a lot of us. So we know some folks will be joining about 5 or 10 or 15 minutes in. Just as a reminder, because we're using the Zoom platform and not a conferencing platform, if you don't mind muting yourself and staying muted throughout the call, unless you're raising your hand during the Q&A period, but we'll go through that in just a moment. So with that, just in terms of getting underway with some of the administrative logistics, we've got several folks on the line here today. Our speakers are lined up with us from Thales and from Hamilton Street Rail, so we're going to be introducing them momentarily. You'll see on the call here several of our CUTRIC staff joining us from across the country. The rail initiative is quite important to us as we get underway with identifying what's the next big project for CUTRIC and in a division of rail that we've not operated in before. So we have Yawen Loa on the line here today, and she is our membership outreach officer joining us from Quebec. We have Jess Smith joining us from the Maritimes, many of you know as our commercialization project manager on electric bus, fuel cell bus, and autonomous smart vehicles. Nadia Ninchevich, who is our vice president, joining us on the line from Ontario. Sira Ali, who has joined us on our commercialization projects team as a coordinator on that project, set of projects with Jess Smith, joining us also from Ontario. Mahnour Ayaz as one of our GIS leads, joining us from Ontario as well. Marie-Ève Asensio-Denis, joining us from Quebec as a membership outreach officer. Titash Chaudhuri, joining us from Alberta, and she is our business development lead. And then we have several of our members, member designates on the line. You could see folks pop up along with some non-members as we've opened up the Rail Innovation Initiative to non-members of CUTRIC at this time, as we seek to identify if there's enough interest here for an innovation project at the scale and scope of where CUTRIC operates, which in this case would be a $50 million to $100 million type of project. So in terms of housekeeping, if we could just move forward, Mahnour, Zoom housekeeping for those of you who operate on MS Teams. We're in Zoom, not too difficult to navigate by this point, post-pandemic or inter-pandemic. We've got the mute and unmute video on video. If you want to move forward one slide, just in terms of the housekeeping elements, you can use your reactions. You can have a live transcript if you need that. You can utilize the chat function, and you can see who all the other participants are on the call if you need to. If you do end up leaving the meeting by accident, not to worry, you can pop right back in. You're not eliminated from doing so. And just to kick things off, we're going to share a short video with you. If you've seen this before, if you haven't, it's meant to sort of inspire the future vision of what we think we can help do in rail in Canada. Thanks so much, Mahnour. So a little bit of inspiration as we head forward into a very complicated area. For those of you who are aware, we haven't really been actively involved in rail innovation through a project. We've done lots of conferences that I'll talk about in a moment, but not in an actual project because it's big and it's heavy and it's a heavily invested industry. So before CUTRIC and its membership actually get involved and start investing in this space, time, labor, and money, we want to make sure that there's enough of an interest in these spaces where we operate, which is on the cutting edge. So if we go forward one slide, I'll just walk you through the companies that have registered to have participants on the call here today, updated as of 11 a.m. May 3rd. So thank you very much to all of those companies and organizations, as well as Infrastructure Canada that's represented there, and several other government contacts throughout the federal and provincial governments. We'll move forward to the agenda. Today's agenda, we are going to walk through some of the core trends, remind folks, if you missed the last session, what the core outcomes of those focus groups were. And then we'll move into the core of today's material, which is passenger data analysis from rail to bus, in particular, rail to bus transit scheduling integration, and what that can mean for improved passenger services across Canada. And then concluding with what can that mean in terms of a rail initiative type of project that we could actually move forward with in Canada in that $50 to $100 million range, or as a feasibility and planning study down in the hundreds of thousands or millions of dollars. Those are really the scopes of what we operate within at CUTRIC. If we go forward a slide, we're just going to walk you through the highlights. In terms of a recap of the last session, for those of you who are familiar with what we walked through in the last session, if we move forward one slide, Mahnur, just to remind folks, the last session was focused very much upon the integration of e-charging equipment at rail hubs. And that was pretty important to us in terms of that kind of activity and what we could do in that space. We're going to go through some of the recap of that meeting shortly, but just to give everybody a sense of what's coming up in this session first. If we were to move forward one slide, we're going to go through the highlights and core trends of timetable synchronization. So here, in terms of passenger data integration, the theme here for today is passenger data integration from rail to bus. And we do know that timetable synchronization plays an important role in advancing integrated bus rail systems. If we go forward one slide, we know that passenger data analysis enables riders to enjoy a smooth transfer between bus and rail. And if we do hear one complaint across Ontario, it is very often the fact that the rail or the train in particular, let's say a GO train arrives at a station and the bus is not waiting there for me. And so we heard this a lot at CUTRIC over the last several years. Things have gotten better over time. Certainly Metrolinx is putting in a lot of effort here, but it can always be better. And if we then map this onto Via Rail across the country and Via Rail stopping in tandem with local public transit, we know it's an ongoing issue, and convenience is a critical factor in getting people into transit, whether it's rail or bus. If we go forward one more slide, we could see that from our literature review at CUTRIC, that light rail transit in particular, there's quite a lot of studies across the country demonstrating that LRT users are often suffering long wait times for onboarding at bus stops. So even within a system, the alignment of LRT with local bus in the same system seems to be a challenge. And it's coming down to software, data sharing, data integration, scheduling, updating, and then passenger information in real time. So we know that's an issue. If we go forward one more slide, several research studies have demonstrated that there is a need for improved modeling software to understand the cause and effect of unsynchronized schedule problems. So maybe it's that the system is set up to make sure that the train comes and the bus is there, but then it gets off course and there doesn't seem to be a fantastic amount of software out there available to transit agencies or modeling tools to figure out what the ongoing causes and effects are. Like, what's the issue in the system that's causing constant misalignment between train and rail arrival and bus scheduling. And some of it could be systemic and some of it could be ad hoc, but nonetheless, there's not a lot of tools out there. If we go forward one more slide, we'll see some of the other factors we pulled out of our lit review include things like rail and bus arrival and departure times, operating speeds, posted speed limits, the traffic that is often assumed to be ad hoc and unpredictable, but which is actually quite predictable in environments where traffic and congestion are monitored on a daily basis. And then the overlapping of public information systems, both at locations on public devices as well as personal handheld devices, and the need for potential infrastructure upgrades that might also be required in order to support the kind of data sharing internal to a system or across systems from rail to transit to really get that optimized ability of transit through rail and bus to really synchronize for passenger optimal experience. So if we go forward now into the introductory section here, we're just going to walk you through the theme as we see it unfolding, some of the elements that came out from our past focus group on these core components. If you go forward one slide, Mahnur, folks can see here that in our past focus groups from 2018 onward, which then form the basis of our rail innovation initiative, our members did identify that if we are going to get involved somewhere, this rail to bus transit scheduling issue is a problem. whether it's a software or an infrastructure or a passenger modeling activity, somewhere CUTRIC's going to need to play a role. If we go forward one slide, you could see that this is the third theme in a 6-theme lineup. And I would have predicted about a year ago that hydrogen rail and battery electric bus integration with rail stations is more important than passenger integration, but it's turning out that passenger integration among our membership heading into 2023, post-pandemic in particular, and now in the midst of violence on transit that is adding to a perceived reason to not take transit, is increasingly going to be important in order to attract people back to the convenience of transit. And now just to give those folks who are new to CUTRIC a little bit of quick background context, if you go forward one slide, you'll see where we started at CUTRIC back in 2016 to 2018. We developed a massive national consultation process, published a report in June 2020, just as the pandemic had hit, with Transport Canada, identifying top 10 technology areas for passenger freight rail innovation. One of them was hydrogen demonstrators and battery electric demonstrators, which CP and CN have run with, and they were actually part of that consultation process. But the other core elements in that report, which you can still read online if you'd like to, is data and data analysis for passenger recognition, understanding the passenger as a client, and then mapping the passenger journey through stations, onto trains, from trains, through stations, onto buses. So that was highlighted there, and that's why it's one of these core themes. Since that time, we launched a couple rail conferences. We did them digitally during the pandemic to see if this had any feet. And during that time and in parallel, we ended up helping the federal government develop its zero emissions transit funding program for buses, the Zero Emissions Transit Fund, and the feasibility and modeling program, the $10 million program that goes alongside that, that allows CUTRIC as a nonprofit to do modeling of the electric buses and fuel cell buses. And now we'll be working with Transport Canada to see if there's a good reason why we should have a similar program, but for rail, specifically rail passengers and transit passengers, the kind of feasibility work that we see from the literature review of sources we just went through and from our own members as a highly relevant area for CUTRIC to be involved in. So we do think, and I increasingly believe, that this is a critical area to getting people back onto transit, not just post-pandemic, but in the midst of violent episodes of perception and reality. So if we go forward one slide, just to dive a little bit deeper into it, we did a bit more of research into where could enhanced rail to bus scheduling on integrated transit systems work. They could contribute to zero emissions goals. They could accelerate transit ridership recovery. And they could provide additional community benefits in terms of optimized bus arrival and departure from stations. They could help increase transit demand overall while ensuring that rider transfers between decarbonized systems are optimized as well. And knowing that we need a lot of people on decarbonized battery and fuel cell buses to pay them off, this is going to be even more important. And then, of course, for Canada, where rail is an ongoing headache in terms of getting it to work and work well and serve the needs of Canadians in a very large geography with very low density, to optimize rail to bus operations through synchronized scheduling to maximize reliable communication with riders. And if we go forward one more slide just to conclude before we head into our core speakers for today, we already know from Stats Canada that the number of passenger trips we have is about 120 million. And that was in 2021, we pulled the data just as Stats Can was coming out with that data in September 2022. And we know that from that time in 2022, although there's been recovery, so the data is a little bit dated at this point, there's still like a drop off. And except for Brampton and a couple other small transit agencies, we don't have the full recovery, although most transit agencies are reporting a trend towards recovery, but not apparently on rail yet. And that's interesting. At least in Canada, we don't have the reported stats for rail recovery yet. So we do know that operating revenues are high for rail, and yet that rail constitutes one of the best mechanisms of achieving climate action and rapid, fast, efficient, and cheap passenger mobility across Canada, especially across the GTHA, Montreal, and Vancouver. And lastly, if we go to the final piece of information that we were able to pull out, we did find in the literature that rail to bus transit scheduling can increase the number of rider trips and contribute to that post-pandemic recovery, certainly from Europe. We see that evidence emerging. And we also know that in the last 5 years, technology has rapidly evolved, in particular with AI systems being integrated into not just scheduling, but passenger mobility and passenger journey tracking, that kind of capability could be brought into Canadian systems increasingly, and worldwide projects have demonstrated the value of timetable synchronization as one of the core mechanisms for making their nation, in those studies, a rail-dependent nation, which is where we really want Canada to get to. So having given that overview and a little bit of that brief, what we're going to do now is move into two of our core panelist speakers. We've asked two of our core members to speak on the issue specifically of passenger data analysis and or its relationship to rail to bus transit scheduling. And for those of us in the GTHA or in Ontario, we know that the Ontario story around LRT has been a challenging one for a lot of transit agencies, but a real success story has been in Hamilton, where there's been a lot of discussion. And so if we move forward one slide, we have here with us Maureen Cousin-Heath, the Director of Transit at Hamilton Street Railway. Many of you are familiar with the LRT design and deployment project plans in Hamilton. It's a hot topic, and we've asked Maureen if she could share with us not just the plan there, but what the hoped for plan is around passenger data integration for that LRT to bus scheduling for the greater Hamilton area. So with that, I want to turn to our colleague, Maureen Cousin-Heath. I'm going to turn the virtual microphone over to you. And Maureen will give you the signal in the chat function of the time countdown. And we're hoping to have enough time for questions at the end and a bit of a panel debate and discussion. So over to you, Maureen.
Perfect. Thank you. So perfect. Next slide. We'll skip right into the good stuff. So as Josipa mentioned, here in Hamilton, we are undergoing a number of transit building projects simultaneously, which is, I'm not sure if that's the smartest way to do it, but that's the way we're doing it. We're going to do it all at once. So we have looked at our existing transit network, which is over 100 years old. We started with a blank piece of paper and said, if we were building a transit system for tomorrow today without being constrained by what it used to look like or what is currently on the roads, what would we do? And of course, a part and parcel of the redesign for us here in Hamilton is predicated on the fact that we are at the beginning of our LRT journey. We don't anticipate our train to be operating for a number of years yet. I'm looking probably 8 to 10 years out, although that date still remains a bit of a question mark. So we have a build out plan to get there and be ready for kind of opening day, as we call it. But first, I'll start with kind of how we got there really quickly. As with any municipality, there's always a body of work over, 15 years between sort of where you're starting and where you're going. And Hamilton's no exception. We started working on integrated development strategies back in 2006 with a Rail Ready report, a rapid ready report in 2013, launching our 10-year local transit strategy in 2015. And if we can flick to the next slide, then we moved into our customer-facing project. Sorry, can you just pop up the next slide for me? Perfect, thank you. In 2018, we started our Voice of Customer project, Re-envision the HSR. Then in 2019, the LRT project was canceled. And then in 2021, it became a thing again. And of course, in 2020, we had a pandemic. And then in 2022, we decided to make the Main Street in Hamilton a two-way as opposed to one-way. So all the while we've been trying to re-envision the HSR, we've had unforeseen circumstances kind of working against us and throwing lots of curveballs into the mix. But in April of 2023, we presented to our Public Works Department the HSR rail design and our redesigned Rail Ready network. So it's been a long journey to get to where we are here today, but we are finally here. Next slide, please. So our Re-envision the HSR project, you'll hear us talk about it a lot in Hamilton. It really is a unique partnership between our internal city staff and a variety of departments here, and also McMaster's Department of Civil Engineering. They were engaged to conduct a systematic assessment and optimization of our network. And our Re-envision exercise focused on two key elements. Number one, reconfiguring the bus network using data, qualitative and quantitative data, and also exploring the voice of customer on perceived and desired quality of service, What do you need your transit system to look like, to be like, to feel like, to get you out of your car and onto public transit? So those are really sort of the basic principles of the re-envision the HSR. And through all that work, next slide, please, we came up with our guiding principles. And I'll not spend time dwelling on these. These are public on our website, but really what it speaks to is a transit agency that is focused on continuous improvement and change, and our commitment to our employees and our customers. We really believe that moving forward is going to require a will of not only council and not only transit staff, but the community as well. We can put all the buses on the road we want. We can have a train zipping through our city, but if our service isn't reliable and frequent and attractive, we will not be able to get people onto our system. So we felt that it was really valuable to spend some time making sure that we knew what our commitment was to our riding public, and that's what the guiding principles have provided us with. Next slide, please. So through the public consultation and the core elements from the voice of customer, probably to the surprise of no one on this call, what we heard from our customers is they want fast trip times and reduced transfers, because transfers are failure points for all the reasons Josipa just talked about a few moments ago. They want the buses to be on time. They want the service to be affordable, and they're looking for increased connectivity with other modes of transit. So we have Go Transit, we have Via Rail over in Burlington. So they're looking to be able to connect regionally quickly and efficiently. They're looking for improved service on weekends and holidays. Like many transit agencies, our system has long focused on the Monday through Friday patterned commuter. And that's what we've always seen as the core of our ridership. But as we recover from the pandemic, I think most of us are learning is that our opportunities to increase our riderships are probably on weekends and holidays, and not in the traditional commuter space like we've long held. And they're also looking at bus stops and transit terminals as public spaces instead of, kind of that unwelcoming pole in the ground. How can it really be a public space? How can we provide exceptional wayfinding solutions? How can we make our bus stops an inclusive and welcoming and safe place for customers to wait? That's of critical importance. So next slide, please. So as I did touch on, our network is over 100 years old. Most of our routes are downtown driven, and they really have not changed a lot. Hamilton, of course, has a mountain in the middle of the city. And so we had some operational vulnerabilities, which always present risks in how reliable our service is. And we have a large rural component as well as an urban component. So there's quite a bit of variation in route frequencies and service spans. So we've got inequitable service throughout the city. So we were trying to solve a lot of the problems that come from an old network that has been invested in, piecemeal and ad hoc, typically by taking service away from some areas to give it to others. Next slide, please. And as I just mentioned, the changes have been incremental. What we also know is that our existing network isn't going to meet the Hamilton's growth projections over the next 8, 10, 50 years. And we know that it is not responsive to regional travel, and it certainly isn't rail ready in its existing formation to feed and sustain our LRT into the future. Next slide. So I spoke about the partnership between McMaster University and HSR. I did put the link, and happy to share them with CUTRIC to share with participants of the call. There are a number of staff reports and our service-related appendices that were issued at our April 3rd Public Works meeting. I would call attention that one of the appendices to those documents was the McMaster report from Dr. Motaz Mohammed. By going through the 80 pages of his technical report, you will really see an excellent roadmap of all the data analysis that was undertaken to get us from start to finish. And I really encourage you, if you're looking for kind of how to use good data to revamp your system, that report and the people at McMaster that we worked with are truly exceptional and provided a great deal of robust information for us. Next slide, please. So when we look at the data compilation and how we used our data sets to build the new network. As I mentioned, we used the McMaster work. We looked at the City of Hamilton's guiding plans. There's no municipality that doesn't have official urban plans, economic plans, and transportation master plans to guide you. We looked at the geography, demographics, the growth plan, population projections, and of course, then a healthy dose of qualitative data that we captured through our Voice of Customer survey that focused on both users and non-users alike. So when we put all of the quantitative and qualitative together, we knew very clearly what we needed to focus on to build a system that could connect accessible conventional service into the LRT to come. Next slide, please. Transit is really rife with data. We're all very data rich, and it is often difficult to have all of the data that comes frequently from different pieces of technology or different pieces of software. It's hard to get them all together into the same place, but our empirical data analysis included sort of your traditional markers you would expect. We looked at ridership, we looked at our network robustness, travel time, coverage, land use assessment, and all the regular key metrics you would expect to in transit. So I won't belabor those points, but it was a fulsome analysis. And we also focused, of course, on the city's goals in the longer term, like major employment centers and trip generators and neighborhood density, also thinking about where future housing developments were going to come that would be tiered to different income levels so that we can put our service in the neighborhoods that are most likely going to be high users. Next slide, please. So our lofty goals, we expect that the new network connected to the LRT will hit a bunch of markers to increase our ridership, improve the use of the infrastructure. We're really seeking to improve accessibility and mobility, make regional travel easier, connect more effectively to GO and VIA, and connect obviously to our LRT, and make sure that we're maximizing our service reliability by minimizing risk to customer trips. The customer experience is really something that through the data analysis, you have to pay attention to. If you're getting those transfer connections right, eliminating transfers where possible, those are all things that eliminate fail points and therefore increase customer satisfaction. Next slide, please. So in terms of what's new in our new design, we've migrated to a hub-based network instead of sort of the old-fashioned hub and spoke rather. We've got a hierarchical route structure, and we've expanded all of the rapid transit coverage. You'll see in some maps I'll show in a few moments. We've improved all the connectivity. We've decreased the number of transfers, and we've improved plan to improve the transit infrastructure at streets, hubs, and gateways, and offer more connections to the LRT. Next slide, please. So our terminals and gateways will be strategically located at different geographic areas, and we'll make sure that we have appropriate infrastructure at our hubs, our ends of line, our terminals and gateways and loops. Next slide, please. Just very briefly, we mentioned a route hierarchy. We're going to 10 minutes on rapid routes, 15 minutes on core, up to on-demand, request-based. And I think when we talk about the connectivity between bus and rail networks, that's where really, if your rapid routes that feed the LRT are at a 10-minute frequency, then perhaps the connections become of less importance, because stepping off an LRT train, of course, depending on the service frequency on that train, if you're coming off an LRT and you know that next bus at worst is only 10 minutes away during peak, the concern for a customer is lessened, but it's certainly something to pay attention to make those connectivity points super easy for customers. Next slide, please. And we're also going to change our service standards to make things just a little more consistently. We have some things where they're currently inequitable across the service area. Next slide, please. And this is just a simple, everybody recognizes it's kind of a screenshot from the ride guide that will come in the future. We are able to demonstrate the number of connection points with our bus network to the purported LRT stops. And at a glance, it highlights to people that we will indeed be rail ready when the new network is built. Excuse me, next slide, please. So for those of you that have followed the Hamilton story for some time, you'll know we have the BLAST network out there. It's been around for a while. It was a 5-line rapid system. And you'll see there's been some significant changes in it as we've worked through our network redesign. Next slide, please. And here you can see it in a different iteration. You'll notice that there are 6 lines now. So we have to rename it, and we haven't thought of a new one yet, but we're moving on with an improved and increased rapid transit. You'll also notice that the area that the rapid transit routing will cover is a much larger geographic area in the city of Hamilton, making even more Hamiltonians within a reasonable distance to access the rapid network. Next slide, please. Just a very quick side-by-side comparison of kind of the former and the new proposed. So you can see the difference is a little bit better, and you can see far more connectivity out to the eastern side towards Stony Creek and beyond. Next slide, please. That's the system map. It is currently open for public engagement. And May 11th, we have our very first kickoff of public engagement sessions. The map's been all over social media. The early response from the public and our counselors has been very positive. They definitely see the intentional connectivity to the LRT, and they see it's visible on our sort of pre and post map. If you compare them side by side, it's visible where the improvements are going to be and where the new service is coming. Next slide. What it will take to bring it to life is about an additional 600,000 hours of revenue service. We'll be driving an additional 12 million kilometers, 19 new small buses, 43 new articulated buses to bring the rapid portion of the plan to life, and a couple new 40-footers, and then about 13 new routes all in all. Next slide, please. Finally, one of the things we wanted to highlight is we talked a lot about decreasing the opportunity for transfer connections and make a more seamless one bus travel option for our customers. We heard loud and clear that that's what they were really looking for. And this slide shows you sort of the one with lots of red on it is our current iteration. The one with lots of green on it is the future state. And it shows our ability to reduce the number of transfer connections that people are going to have to make to transfer between hub to connecting route. So it's a visible improvement, and that is sort of a data-centric way at looking and representing to the public that we're hitting our markers on what they asked us to do. Next slide, please. Now, in terms of where we are on our LRT project, as I mentioned, we're fairly early in the process. We've been working at it for about 2 years now. We are working through the agreements with our partners in Metrolinx, and certainly we can talk about some of the challenges that we've seen in integrating bus and rail so far and overall in the project. So I would start with the project timelines are mismatched. As I mentioned, we started our re-envision network redesign kind of in 2018. The LRT was on again, off again, and is now back on again. And so it's been somewhat difficult because those timelines aren't in sync, but it is still manageable. One of the things that we know is the service levels for LRT are not yet finalized. They are not yet public because they're not yet finalized. So we are trying to build a bus network and timetables, knowing full well that we're probably going to have to tweak and massage that once we land with what the LRT time is going to be, because connecting those schedules and synchronizing them as much as possible is going to be really critical. We're hearing early public interest in the really granular level of details. So customers have said, that's great. I see your map. I don't care. I want to see the bus schedule. I want to be able to look and see if my ride time is shorter or longer in the new network. And that's difficult because you don't always want to release that level of detail too early when you know it's subject to change, because it's reputation management and customer experience management. You don't want people making decisions that they're never going to try the new network out based on what they see early, when it is still subject to probably several years worth of change and migration along the route. We also know we're going to face multiple years of construction cycles, and that will be prolonged detours and a disrupted customer experience for sure. We'll be looking at what we can do to mitigate that. And of course, communications and customer support through that construction is going to be very critical. Bus bridging service support for LRT, it is unknown to us what that operational impact will mean for us when they start operating, but we have been told by some of our counterparts that are further down the road or have operational LRTs that is something they underestimated, the importance of thinking about what happens when the train breaks and you need to bridge with bus service. And I think that is an exceptional asterisk on our conversation today. How do you change your customer information on the fly when it is expected to be between bus to LRT, but then the LRT isn't working, so now it's bus back to bus? You know, often in transit, we still struggle with on the road detour notification today. I can't imagine the complexity that it will come down the road when we're trying to do it between potentially an external agency as well. And that, I think we're going to talk about some of those barriers as we get into the questions and answers. Some other sort of integration challenges that we're seeing so far is there's multidisciplinary teams across divisions and across departments. As you can well imagine, there are multiple areas in the city of Hamilton that are impacted by this. Sometimes it's hard to get everyone on the same page. Some people's interest is at different phases of the project, depending on the nature of the work that they perform. And it can be sort of a bit of an unwieldy amount of people at times to get all in sync. And I think beyond just divisions and departments, it also goes into our partnership with Metrolinx. As we're working on our growth plans, they're working on theirs as well. They're working on their station redesign master plans. They're working on BRT projects in other areas that will come into Hamilton. And so sometimes, and it goes back to the project timelines, sometimes all the different stakeholders have various projects on the go that don't quite align either. And it's that constant need for communication sharing when you're not quite sure how or when that will impact your system. And then finally, haven't really seen it yet, but know it's probably on the horizon. When you're looking at this kind of project, you're looking at something that is, you know, potentially a decade. When I look around myself, my staff, and the broader project team, you know, in that decade that there are going to be personnel who will come in and exit your agency. So it's kind of the continuous carousel of subject matter experts that you're onboarding throughout the project, and the loss of the historical knowledge. So that's certainly something where records keeping and data management really will carry the day as time progresses on the project. So those are my slides. I'm happy to turn it back over to Josipa and any questions. As I said, we're down the path on our network redesign. We're early in LRT integration, but what we have focused on is making sure that our base bus network is reliable, fast, and frequent, so that future connectivity, when we get into those, the couplings of the schedule, should be an easy experience, and we'll use technology. Hopefully we'll both be using the same technology, working together so that we can do so efficiently.
That's fantastic, Maureen. And you finished a little bit early, and we do have a couple questions coming in for you already. So I'm going to take the opportunity to ask you just 1 to 2 questions before we go to David, and then we'll have a plenary panel session.
Sure.
Given I still work in McMaster University, still teach, so I take the service regularly, and I love it. But the integration between Metrolinx and Hamilton has been pretty good, but between VIA and Hamilton, another question altogether. So one question coming in was, how much dialogue and planning is there with VIA Rail? and Hamilton's public planning for transit to the extent that Via Rail trains arrive. People get picked up, and then they're intending to have their endpoint in Hamilton.
I definitely think that's probably our system's biggest area of opportunity, when I think we do focus a lot on our connectivity with Go. I think we haven't done enough justice to trying to dialogue with VIA to make a better connection between sort of the federal rail system. And I know, Josipa, I've heard you've talk today and other times about really how fast and frequent VIA service is really important to the country at large. And I think that as that starts to take hold, and as there's more focus on that level of rail service, that it is definitely something that transit agencies are going to need to turn their mind to more effectively.
Yeah, for sure. And that's helpful. And then one additional question before we turn to David. There's lots more in the panel, but one was in one of your maps, you had indicated an expansion out eastward, more of transit towards Stony Creek in that direction. One of the participants has posed the question of, as rail gets extended out to Niagara and Niagara has regionalized, there is some traffic between Niagara and Hamilton. And what is the thought there? Or is there extra special or any level of thinking around the integration so that people don't have to go all the way into Hamilton to come out of Hamilton on the train, a bypass or a bus bypass, or integration from Stony Creek to Niagara for that side of the equation?
For sure. So I really kind of gave the Coles Notes version of the map and the new network, but certainly what I can say is we see a very intentional shift at our routes now using GO stations as a major hub. So for example, most of our downtown routes right now terminate at McNabb Terminal in downtown Hamilton. There is an intentional focus and plan to move to West Harbour GO. And there is intentional planning to use Confederation GO Street station out in the east. And I'm sorry, when I was presenting, I did say Stony Creek was west, and it is most definitely not. But so it was backwards on my screen. That's what I'm going with. So anyways, no, we see the importance of the GO stations definitely becoming a place where we will be terminating or using as an access point for many of our routes so that that connectivity is built in. When we talk about the connection, one of the challenges that we have is, GO Transit doesn't always call us and say, this is when we're going to schedule our trains. So we're building our bus schedules hoping that they fit with GO. And I think that highlights one of the key problems that we're going to have, is that there has to be an intentional part on both parties, both GO or Metrolinx and the local transit agency, to try to align those schedules as best as possible.
That's really helpful, Maureen. We're going to come back to that theme at the end in the panel, just in terms of what's on the horizon with the two-way communication for bus to rail, because often what we've heard at CUTRIC is there's the one way of kind of the rail system letting transit agencies know when rail will arrive or when GO buses will arrive. But what about the feedback loop of all of the transit agencies letting Metrolinx know when they ought to arrive? And that doesn't necessarily seem to have been as well developed as perhaps many of our members would like. And we're going to see if we can foster that dialogue and what the solutions are going forward. We do have an additional last question I'll just put out there right now is the new projects that you've mentioned, will they be released by Metrolinx or the City of Hamilton?
Sorry, which project? Like the LRT is a Metrolinx project, but the building of our new network, that is the City of Hamilton project. Does that clarify?
I hope so. I'll just leave that to the question poser. I've let the individual know if they'd like to come back during the panel. Yep, seems to answer the question. So that's right. That's great. Thanks so much, Maureen. So with that, folks, I know that there's a few other questions coming through, but a couple of them are more applicable to both speakers. So I'm going to hold on those to the panel. And with that, we're going to switch over to our next speaker from one of our founding members, Thales. We have David Beach, who is representing the product line architecture of autonomous systems at Thales. And Thales being one of our founding members as a rail member at CUTRIC, helping us to figure out what the rail play could be at an innovation consortium. We want to welcome David Beach to the digital platform. So David, microphone over to you, and we'll probably have a couple questions for you to kick things off before we then get into the panel dialogue.
Okay, thanks, Josipa. So yeah, as Josipa mentioned, I'm the product line architect at Thales in Toronto, the research and technology team, and we've been working for the last 4 or 5 years on a train autonomy platform. So that's my main focus. But so I'm going to take a little bit more of a, I think more of a technology view for obvious reasons, and look at the rail transit needs. But I'm hoping what I can show is that there are a number of innovation challenges that we are, I think, well positioned at this time to address. And there are innovation challenges that to some extent overlap and are common to both rail and bus, or rail and road. So next slide, please. So I'm just going to start by talking about generally what the future cities need mass transit to be able to do. And so again, I'm usually coming from a rail perspective, but I think this is fairly common. Obviously, and this is from both the operators, which is generally the people we are thinking more about, but also from the point of view of the passengers. So obviously safe and reliable is a big one, not just the reliability of the equipment from the operator's perspective, but also consistency, so that the riders can know that they can plan around things and it's going to be consistent service. Improved service is an obvious one as well. Kind of speaks to the idea of optimization, improving the efficiency of the service. But one other thing that falls under that from that is sort of related to that is related to what Maureen was talking about, which is if there are ways to reduce deployment times. That's a big one for us as well, because it gets people off of less green modes of transport and onto mass transit quicker. And so deployment times and project building times can be a big bottleneck. Obviously, lowering costs, life cycle costs is good for operators, is good for riders if you can pass along affordability improvements to the riders. And then the main topic today, obviously, being seamless and interoperable with the other modes of transit. And so I think if you hit the forward key, you'll bring up the main point for this slide. Generally, we look at optimization from a technical perspective. Optimization, synchronization are almost two sides of the same coin. And I think Maureen actually spoke to that as well. If you optimize enough so that you have 5-minute service, then your synchronization problems are almost solved, because when someone shows up, they're going to get a ride within the next 5 minutes. So there's a bit of a balance there, but it all depends on having the data, not just the historical data, but what we look at a lot more often is the operational data. Being able to support things like just-in-time scheduling, demand-based scheduling, and basically understanding the dynamics of the networks as a whole and how they overlap. So next slide, please. So these are sort of the 5 things I'm going to talk about today very quickly, taking us all the way from the sensor side, which is getting the data, to the networks, getting the information out, to either to the processors or the third-party developers that want to build applications for various consumers. Processors are another challenge, another aspect that need to be talked about. Obviously, in any transit system, you're going to have safety certification. It's an important point, and it's more relevant now that we have very advanced algorithms. And then finally, the ultimate thing that you want, which is this application level, large scale processing and optimization. You build up models, and those models are used to produce various degrees of optimization and synchronization. So next slide, or next point, I think, yes, so the bullet point here is that innovation in transit requires, from a technical perspective, that these are all brought together. These are all aspects that need to be addressed. So there's lots of room for innovation in transit, for sure. Next slide. So looking at the sensors, I put a couple of sensors that we're familiar with. Those are onboard and wayside sensors, like might be on a vehicle or at level crossings, or it could be at stations. So there's lots of use cases for these sensors, but generally the sensors and the sensor technology, they need to be robust enough for the environment. They have to be complementary to each other, because in a lot of cases, one sensor technology doesn't address everything. You need to have, it doesn't work when other sensors work. So there's that aspect as well. Speaking about data, there's the data that's coming off the sensors, but a lot of the sensors now are intelligent. So they'll provide metadata or even more processed data that can be used. And things, for example, passenger counting on platforms, is data that can be fed to a back office system and used in some way to to estimate the level of demand at an instantaneous moment. And then also it's much more common now for sensors to be multi-purpose. A good example of that is a camera. Cameras with appropriate algorithms can do a lot of different things. And so we're seeing a lot more of that in the sensors as well, but you have to be able to develop and use that functionality appropriately. So if you just click forwards, I think the overarching message here is that the sensors have to be available for the data that you're looking to gather, whether it's camera data or whether it's vehicle data for maintenance while the vehicle is running. It's a rich amount of information that needs to be gathered. And generally, if you want to do it in a way that's going to give you efficiency improvements, it has to be done non-intrusively. So you can't interrupt service, let's say, in the way that maps may have been built in the past. You have to be able to do these things non-intrusively. Next slide, please. So the next one is the networks, and I'm sure we're all, there's lots of programs going on right now in the country, around the world, looking at next generation networks. Generally for transit, you need things that are secure and performant. That's almost a given. But also you need, if you're looking to do things that are processing data and producing near real-time output or processing models in some sort of, sort of just-in-time scheduling sort of approach, you need time sensitivity, you need ultra-low latency, you need features like that in the network. A lot of these networks need to be able to support the ability to do multi-service edge computing. This is computing at the location to get as much information as you can, and then just sending lower bandwidth or quicker information back to a back office. In transit, a lot of what we're concerned about, we need to know where it's happening. So location services are very important. Some of the newer generation networks have a lot of promise in that regard in terms of providing positioning and location services. And then obviously the ability for different parties to have access to the data, because as it's produced, you want to be able to give people access to it in order to do third-party development or consume it in a certain way. So if you click forwards, I'm just reiterating the point that that we're at a point now where we have this technology that's available, and there's a number of efforts, a number of programs designed around advancing this. So 5G networks, this sort of newer generation, are here, and they're able to support these critical transit needs. Next slide. So now you have the data and you're able to share it. Now you have to be able to process it. So that's obviously another point that needs to be considered. As I mentioned, this can happen at the edge. It can happen in a back office. And again, we're usually looking at operational data, things that can be used with models to provide either historical or in real time to provide outputs that are useful for optimization or synchronization. Obviously, any processors you're deploying in the field have to be transportation certified, so that's always kind of limits the candidates, and rugged and performant. But a big part of what we're talking about here, as Josipa mentioned, was AI data, vision data. It's very high bandwidth. This is one of the main reasons why you need to be able to do edge computing. You need to be able to process it and reduce the bandwidth and make more intelligent information out of that that's more compressed, so you can send it around the network quicker. So if you can click forward, I think I'm just reiterating here that the newer processors now that we're seeing that are starting to arrive are able to combine this level of processing that's needed with the safety criticality and the criticality that's important for the mobile versions. And then also, obviously, you need an appropriate level of processing power in the back office as well. And next slide. So this one is always there. Safety is the key concern when you're talking about anything that's going to be running in a safety critical environment. And so this can come into not just the onboard, but your wayside systems, Obviously, when you're doing any sort of position and speed measurement, when you're building maps, when you're providing advisory information to a driver. So even advisory information is telling a driver how to speed up and slow down in order to maintain a certain optimized driving profile, may have some safety criticality to it. So it's a consideration you have to keep in mind. And obviously monitoring crossings is an important, is a place where this becomes important as well. So I usually use this graphic here just as a very, I think, concise way of expressing the concern. So if you think of a human under the normal expectations for the safety integrity level of a human in rail, it's about a level that you say would go about 20 days without making a mistake. And by the way, that's no sleep. That's just a straight block of time. AI, on the other hand, can go about 100 days. And of course, it doesn't need to sleep. And that's the target for most AI now, for the state-of-the-art AI. But you can see that even when you get to a SIL2 system, which is mid-range, you're now at 1,000 years that the system has to go without making a mistake. Roughly, that's what it means. And then all the way up at a SIL4 function, you're into 1 million years. So it becomes a very challenging problem when you need to have these systems on board, even if they're supporting other functions like optimization or data gathering for synchronization or scheduling. Some of them need to be safety critical. And a SIL4 function is about equivalent to winning the lottery in terms of the frequency that it should happen. So if you can click forwards, I think I just summarizing the slide, reiterating that they're foundational. So they're underneath a lot of these systems. They provide some of the data. For example, position and speed, driving profiles come from positioning systems, and many of them are safety critical. And the need for trustable output needs to be considered when you're building these systems. So this is another challenge that we have to keep in mind. And then the final slide is looking at the data itself and the processing, the big data processing and so on. So this is after you've got everything back in a back office. You've probably done some processing at the edge. Now you want to use the models, you want to build models, you want to develop applications that are going to give you the functions that you need, like optimization or synchronization. It could also be things like mapping, which is very important for rail operators, and I have to assume it's important for many operators, but knowing where your things are and supporting predictive maintenance and so on, that's important for keeping the service running smoothly and not having interruptions. But also things like that can really make a difference in terms of keeping smooth and consistent service is being able to monitor operational anomalies, like driving anomalies. Why is something happening there? What is it an indication of? Is there a root cause that we could address and fix an interruption? And then also, all this data is coming not just from rail, but it's coming from other interfacing modes of transport as well. So it could be coming from freight, where you might have congestions on the go lines because of freight lines, or you might have bus congestion or traffic congestion due to rail traffic. So it's a complex problem, and I think there are definitely ways in which we can take incremental steps to improve across the different modes. Of course, one thing that I haven't read there is that it has to be done while maintaining privacy as well. And so we're all aware that the cameras can give more information than they should sometimes. So that's always a concern as well. And we hear from many of the people we talk about. Some types of data need to be specifically privatized or anonymized. Sorry, my screen just locked up. And we'll go to the last slide. I think I know it fairly well. It's just a conclusion slide. So just as a high-level message, it's what we're seeing, and the trend is that there's mostly in large part to meet these green targets, also because it's more cost-effective. There's investment around the world in transit technology. I spoke obviously from the technological side, but as well from the process side, from the logistics, from administration, and so on. There's investment around the world and a big push for sustainability that drives that. We're well positioned in Canada. We have the world's best AI experts. We've got technology experts that I'm very much aware of. And I think we have some of the more challenging conditions in which to run transit systems. We're often acknowledged by our colleagues around the world as because the Canada office has the best weather variations to test in. So if we can do it in Canada, there's a good chance we can do it in other parts of the world. So we're well positioned to lead these technologies. And so it is a good time. This is a good time right now for a type of innovation hub or an innovation ecosystem that focuses, I think, on rail, but also on the general transit, road plus rail, the entire ecosystem. So I think that's my last main point. I'll open it up to questions. I don't know if I went a little too fast there, but.
That's fantastic, David. And actually, there are a couple questions for you specifically, but I would say, just keeping it on this slide, the last conclusion you have there about a Canadian bus, road plus rail transit innovation ecosystem is exactly what we believe in at CUTRIC, and we've been trying to get to this point. So it's great that you presented the conclusion we're trying to get to. And I do think that it's really highly appropriate now for something like a strategic innovation fund, a federal fund around bus transit and rail integration, eco-innovation. One question coming to you specifically has to do with a visioning exercise based on the technology, and a lot of what you're talking about are the sensors that can inform transit of when the train's on time, when it's behind schedule, safety issues arising, possibly passenger mobility. These are the sensors. And as you said, basically your data is only as good as your sensors, and where your sensors are, that's where the data flows from, as would probably any transit optimization and scheduling from that. Could you envision a day where Canadian Pacific and Canadian National and Metrolinx and VIA, with all of their sensors on board and on track and at stations, telling them when their trains are on time, off schedule, delayed for whatever reason, have a system whereby all of their information is flowing into some nonprofit portal or some neutral portal that automatically informs all the public transit systems on the backbone of that track, so that it eliminates the need for Metrolinx to pick up the phone, or VIA or CP or CN to manually inform those transit agencies, which is presumably a lot of how it happens right now, or just doesn't happen. And inevitably just the train doesn't arrive at the time that the bus is there when it was intended to be there. So could you envision that the sensors could get good enough, and that the AI is powerful enough now, that if we got our act in order as Canadian Rail across freight and passenger, across the GTHA and further all the way up to Montreal, we could have automated controls informing public transit across that whole backbone, so that Maureen and Hamilton knows that the rail is coming late and that the buses might want to accommodate that lateness without anybody having to pick up the phone from Metrolinx or VIA or CP or CN. So maybe over to you for if that visioning is something that you think is feasible within the short term or midterm future.
Well, short term, I think that from a technical perspective, that's feasible. It's the question, I think, comes down to how you get there's obviously going to be some I think some resistance in sharing the data so widely. So it depends on who's consuming the data and how it's shared. I think that goes beyond sort of the technical concerns and more into the discussions with the various operators that are responsible for the sites where the data is gathered. So it's a very complex problem, and of course I can envision all kinds of ways to make it so complex that it can't happen. But I can also think of many ways we could take incremental steps and say, we're doing this now, and there's almost nothing there. We can do a little better, and we can slowly improve things, and and maybe get to a point where we say, okay, actually this is fairly close to what we're going to get as optimal, and at this point we're not going to improve much beyond that. But I think it depends a lot. What we're talking about, what you just mentioned, sounds like to me depends a lot on having the communication infrastructure, which I think is really key, and it's growing. It's growing in Canada, and but there's still some work to be done there as well.
Yeah, and I think you allude to the fact that the technology is possible already, at least at some incremental or rudimentary level. It's really about the systemic will, and that because VIA is federal and Metrolinx is regional and CP and CN are private, it's the political slash business will to make that happen. And our belief at CUTRIC is that will comes from recognizing transit, the public transit bus side of the equation that maps onto this rail backbone as so critical to the mobility and economic development of the country and the regions that it serves, that this kind of coordinated systems information is critical to the economy of the country. We're not yet there where people see that a breakdown in bus scheduling in Hamilton or a breakdown in buses arriving on time in Toronto affects the national GDP, but we need to get there so that those kinds of solutions become willful. And with that, I'd like to invite Maureen back to the stage. And what we'll do is we'll move into having you two spotlighted because we've got several questions here. And we're going to turn to a few of our core questions. And Monor, what I'm going to ask you to do is move forward to question number 2, because we've already addressed question number 1 quite extensively, which was how does this all benefit? But question number 2 that we want to put out there, Maureen and David, is the first off, we'll start with you, Maureen, having heard just on the technology side and then presented what you presented. To what extent are you aware of which rail and transit systems in Canada are already doing like really great rail to bus optimization that we can look to and say, that's the poster child? And what have you seen from that? If there is an example of a poster child in your view.
Thanks. That's a tough question. You're asking me to call out my colleagues for good or bad work. I think, you know, there's a lot of transit agencies like Calgary, like TTC, Edmonton, OC Transpo, and Montreal that have these kind of connectivity issues with both, you know, the federal rail, regional subways, all of the things that we're talking about. And I think, you know, when I go to different sessions and when I talk to my peers, all I hear constantly is that it's got to be continuous improvement, because I think we all know as an industry, we're not where we want to be or maybe where we need to be. I don't know that the technology is fully baked yet. And I think technology is moving so fast in our industry that we're all playing catch up to some extent. So I think they all do it well, but I think we all sit in a space of knowing we need to do it better.
For sure. And I think in Canada, doing it better is so hypercritical because the geography is so big, the density is so low. So the money and cost per kilometer is so high relatively if we want to solve this. So there's not necessarily one poster child out there doing it optimally well, but perhaps there's some examples of incremental improvement. David, I'll turn to you. If you were to look globally, as Thales is a global company and of course based in France, a lot of rail to bus integration in France. Are there examples in Europe or in the United States, North America, where you can say like these systems do signaling integration and data transfer really well that Canadian systems can learn from?
I think I could generally say, yeah, what you identified is what we see is that to this point, there's a lot of focus on it, especially in the EU, but generally around the world. You know, it's people that when they put in new systems, they tend to bring these in right from the beginning, these considerations. So that's another thing we see. And I think it is one of the challenges in Canada that we can make incremental improvements. Incremental improvements require a certain level of infrastructure to be in place, whether it's process, whether it's technical infrastructure, and the decision or the I guess the tough question is, what is the minimum amount of infrastructure we need to make a minimal improvement and that we can build on? That's something that is noticeable and gives people enough of a boost in terms of their enjoyment of riders, in terms of their enjoyment operators, in terms of what they see in their life cycle cost reductions and so on, that makes it worthwhile. I think there's lots we can do, and there definitely are models around the world that we can use to get us started.
Any examples of cities you want to point out?
Well, you mentioned France. I know lots of. It's one of the areas where we don't, you know, in terms of integration. I can say for sure. I spent quite a bit of time talking with a colleague of mine who did his PhD in Tokyo, and he said in Tokyo it was very seamless. The service was very seamless from rail to bus, and everything lined up. Very rarely did you wait more than a few minutes for something when
Yeah,
you
very true. Very true. And I can't speak to the Tokyo example, but I lived for 10 years in the UK and for a year in Germany and a year in France while I was doing my own grad studies. And, you know, as a poor student, it's definitely the case that transit is quite cheap, so you can get around. And it's also the case that as much as people complain about British Rail, you got off at a station, the bus was there within minutes. Now, in comparison, in Europe, of course, as many people in the rail sector know, 80% of rail is passenger and 20% is freight. And in Canada, it's the flip. So we've got 80% freight roughly and 20% passengers. So we can't just say, let's be like Europeans. We don't have the same density of passenger mobility, but it's certainly something to look forward because that convenience was never an issue, but it is certainly an issue in Canada to address. So with that, we'll move to the next question, but we do have a question from Marcy. Marcy, I'll just flag your question there that there's a query here about GoTrans as many Go Bus rail connections where we do simply ask the bus to hold until the train arrives and the driver can see the train and knows when the customers have boarded within that 5 to 7 minutes after the train arrival. So these implemented transfers can occur without the need for data. That's really quite interesting, Marcy. And in fact, if you're on the line, Marcy, we might even be able to unmute you if you wanted to share your insight there verbally, because I think that's quite helpful. I see you there, Marcy. If you're able to unmute yourself, we might have to do that for you. Let's see if we can get you unmuted so we can hear from you. There you go, Marcy. Can we hear you? Yeah, I think we've got you unmuted. Nope. Oh, unfortunately, we cannot hear you.
Can you hear?
Yes, we can. Yes, we can. Over to you,
This is
Marcy.
Anthony. I apologize. I'm actually using Marcy's login because I'm attending on her behalf.
I was going to say you don't look like Marcy now that your face popped up. Yeah, so we can hear you. Oh, we might not be able to verbalize it then. It looks like, unfortunately, Anthony, let's give it a try. Anthony, can you hear us? Shucks, does look like a bit of a delay. So unfortunately, I'll just leave that there because it looks like, maybe Anthony, that was your comment, but it doesn't look like the audio is functioning quite well. But you can see here that already systems are attempting to address this manually without the need for data, and that there are some special cases there where the rail traffic control team can monitor the whole network. So that's something that's quite helpful to be aware of, and thanks for sharing that point in Marcy's name, at least. And with that, what we'll do is we'll turn to the second question, because if you can go forward, Mahnur, one slide. There is this question now about, all right, so we can even do some of this manually, great, but with 500,000 immigrants coming to Canada, and that is fantastic, to Toronto and Vancouver and Montreal every year now going forward by federal policy. It's a lot of new people using rail and passenger mobility. And if we do want to start banning cars and we start limiting cars and tolling roads, which a lot of us do want to start doing in the next generation, that means a lot more rail traffic to public transit. It might not be that the manual solutions are going to be sustainable. So then the question is how much innovation on the automated systems that we just talked about is needed. David, I'm going to start with you here. What are the opportunities federally and provincially, municipally? Like, who needs to get involved in pumping some money into the innovation of passenger to timetable synchronization? Because, you know, Maureen on her own can't get all Metrolinx and Via Rail to do it for her, but it would have to be a partnership. So where do you see on the innovation side government getting involved? What's the opportunity there?
Well, I think the obvious one of the obvious candidates on the government side is probably Transport Canada. A lot of what we see that are a lot of, I would say, approaches or programs that are related to or tangentially related to transit are more geared around supply chain. And so then they're connected to, I guess you could think in terms of labor force mobility, or as you were saying, economic development. Generally, when you're moving people around better and more efficiently, all of those things are improved. So I think the concept of the labor force mobility, or maybe just, I don't know, economic mobility, I don't know, life mobility might be the sort of the approach to take when discussing these at the federal or the provincial or even the municipal level. But I think, yeah, if we're talking about where in the federal government these programs are probably best situated. It might be in Transport Canada, but also any of the agencies that are concerned with economic development. This is going to be at the top of the list as well, or at least near the top of the list, I would hope.
Yeah, we certainly agree. I mean, Transport Canada historically, at least in the last 10 years, really had a lot of its R&D funding removed, especially in the first 5 years of the current government, although it went through a few iterations. But that is starting to change, and Transport Canada is getting its R&D budget back. And it is a natural place at the federal level for Transport Canada to be involved here. Provincially, the big question is this innovation for ministries of transport, given that MTOs typically don't do innovation. They do bus funding, but they don't do bus innovation. And in Ontario, at least just to use the Ontario example, MEDCAT, which is the Ministry for Economic Development, Job Creation and Trade, doesn't do bus or transit innovation, but they do innovation in economics. So we very classically across 10 provinces have the same structure where ministries of transport do bus infrastructure, but they don't do innovation, and innovation and economic development ministries don't do bus and rail because it's seen as public transit. And that is a gap right in the middle of how we govern our societies that impedes this. So Maureen, over to you from your perspective, municipally, there's only so much a city can do and foot the bill of for it to pay for like an optimal passenger data timetable synchronization with Metrolinx and VIA and all the partners. Who needs to do that and what level of government needs to get involved? How do you see that?
So I'm going to pass that right on up to the top and say that that's the federal government's responsibility. They have to be the champion. I look at it from the standpoint of when you had mentioned that passenger trains are 20% and 80% are freights. I believe that it's sort of widely known that passenger trains get held because freight trains take priority. And so at the end of the day, if we're looking at every transit system feeding into the passenger rail system, if they play second fiddle to freight, and I'm not saying that's wrong, but if they are automatically sort of waylaid by the freight schedule, then it all rolls downhill. So to me, it sort of sits at the federal responsibility from a climate change perspective, from an economic development perspective. Municipalities can't take on innovation on the base of our local taxpayers because we tend to rely on them very much so for our operating costs. And so to me, if we're looking at a transportation network that covers coast to coast in Canada, it's got to be the federal government that champions that.
That's super helpful, Maureen, because it is regional and then it's also beyond region. It's cross-provincial in some cases. If we look at the Montreal and Quebec corridor down to Windsor, I mean, we're talking about a very large portion of the GDP of the country that moves along that backbone. And you can count at least 24 public transit agencies from Windsor to Quebec City that are dependent on the arrival of trains in some way, shape, or form. And so it does look like we can't get your audio to work, but nonetheless, I think you said it was Anthony, right? If I didn't taking Marcy's line there, but there's some good commentary there on the side about the connectivity assessment tool, helping to understand how many connections there are and if we can make that work with partners, and seeing if some of that data analytics and some of those empirical data analytics can be fed in from real world conditions into optimized schedule trips. So that's some very good information. We will include that in the report from today's meeting about what's already happening. It's just too bad we can't get the audio to connect properly, but let's see. Though unfortunately we still can't hear you. That shucks. So some goblin in between you and us, but we'll figure it out on the audio side for next time. It's a very good commentary, so thank you for that. And with that, what we're going to do is also we have a couple more comments and then some questions that were sent to me directly. So if we can go to the next question, which does map onto two of the questions that were sent to me directly. We've worded it a bit more lengthy here, but as we let Maureen and David know, one of the ongoing queries that we get from our members is about passenger data being like a meta level and also granular data element. Like there's the granular element of this person, Josipa, gets on a bus here, gets there, connects there. So that granular level is my personal journey. And that's important. But then when we add up all the people moving from here to there, that population level of flow is very important at a meta level in terms of where people are getting like stuck, right? And where the congestion's occurring. So transit agencies, both rail and bus, are just now, in essence, waking up to the power of big data. We've seen that at CUTRIC with a lot of our transit members who don't have a data analyst on staff. That's not even a job that they hire for. And one of the first postings for data analysts in transit specifically occurred about 4.5 years ago. So it's that recent that this has become a thing. So we're aware of that. And our question too, and we'll start with you, Maureen, is where do you see big data as not only an employment role at your agency, but as a thing that you are mandated to do as the director of transit and report on in some way? Where do you see that in rail and bus operations, especially around that passenger experience, having the greatest impact on your transit system? So we've talked about passenger integration scheduling, but maybe we're missing the bigger big data piece.
Yeah, I think the big data really drives the customer experience, right? And I think, I can speak from Hamilton. We have a data analyst. You are correct. It's a newer role in transit agencies. It certainly isn't something that I remember from even 10 or 15 years ago. And I think we are at the start of that journey as opposed to a mature market when I look at BI in transit. So for us, it's got to be continuous learning. Like I said, I would say we're light on it. We have more data than we're able to consume or meaningfully use available in our system. And it's finding a way to take it all from a multitude of sources and turn it into something that's meaningful to help us drive decisions. So I think you're going to see for many transit agencies, that's going to be something that's a much greater focus, especially if we combine with tightening of municipal coffers, recessions, sky high expectations on moving to electrification or hydrogen fueled buses, where the costs are different than what we now know. We're going to have to use big data in a way that we never have before to drive down our costs and open our eyes to different ways of rolling out system efficiencies. So I think the landscape today will look vastly different in 5 years.
Yeah, and adding the cost of decarbonization, we just had this large discussion at the H2 convention in Edmonton, where I put forward what we've been hearing from a lot of our members. As transit agencies go to decarbonization, they're buying battery electric buses and chargers and hydrogen fuel cell vehicles, and the price points are just astronomical for this stuff. And we're believers in it. So I say that with the recognition that it's very high cost to decarbonize. One of the unfortunate challenges is, does that mean less service? Because there's just not enough money to decarbonize tomorrow and go to battery electric and hydrogen fuel cell without reducing the number of buses and drivers with the same pot of cash. And so reduction of service is not an option, but decarbonization is a mandate, and nobody has enough money across 3 levels of government to make it all happen. So then the question is, how much can we save money through system efficiencies, and how much can big data actually save cash in between the interstices to not avoid decarbonization and to not lead to less frequency and less service? David, over to you, because we've often heard that we innovate these systems. We have the big data systems, we have the sensors, but we often export them outside of Canada, and we're not often incorporating them in our transit agencies in Canada. That was a narrative that was quite prominent pre-pandemic. I don't know if that narrative still holds in industry today. So over to you for where's the big data opportunities that you're seeing in Canadian transit?
I think there are quite a few, and certainly using big data to provide performance improvements for the network. So better driving profiles. These are something that's common. Looking at ways to find congestion points and even adjustments of things like dwell times at stations. These kind of things I think are sort of first out of the gate, maybe low-hanging fruit, because you have a lower dimensional data set that's mainly position and speed, and you can start to look at what little improvements can be made. I think the holy grail for big data, and I'm not sure it's a very complex, it is a very complex problem, and I'm not sure if it's something immediately approachable, except incrementally, is really looking at the multiple networks as a whole. So when you have this data for road systems, and you have something for rail systems, and maybe even for freight systems, you may be able to sort of cordon off areas and start to say, hey, can we really model and understand what's happening in an area that can allow us to make little adjustments? But The challenge there, I don't think so much as the big data as it is coordinating amongst the various people involved, because the data can tell you you should do this or you should do that, but then you have to get the agreement of the various people to move forwards and actually execute on any of those actions.
Absolutely true. And we haven't even opened up the dialogue of once we get it all optimized in Canada, I truly believe anything rail is a North American USMCA issue, especially when we're talking about the amount that freight controls our passenger mobility. We do have Amtrak trains coming in. CP is now truly USMCA expanded all the way into Mexico. So being able to bring on CP and CN and try to identify how they could support this optimization work across Canada, the United States, and Mexico so that the entire network is starting to be optimized for Canadian benefit out of self-interest on our part, I think is going to be one of our next big dialogues because there's no other way, in my view, certainly, for this to be just a local solution that in Canada we solve on our own given the freight occupancy of rail. So with that, we are going to turn to our speakers now for their final thoughts. Maureen, I'll turn to you first for any final thoughts on this issue. What needs to happen in advice? If you had the ear of Mr. Algebra, who's the Minister of Transportation federally, what are the final thoughts about what needs to happen here for optimal passenger flow and synchronization of timetables and big data?
I think we have to find a way to partner and collaborate between the private sector and the public sector. I think it's going to take a lot of political will at all three levels of government and right down into the transit agencies. There's private carriers that need to be involved in this table and at this conversation as well. And I think that one of the big pieces that will need to be considered is the privacy piece and the data sharing between multiple agencies and the protectionism for privacy and how the data is used, maintained, and stored. So I think those are, a couple of the challenges that we've got and who we need to have at the table.
That's very helpful, the privacy being critical within that. And David?
I think I'm mostly going to echo, I think, what Maureen said, because it takes, I think one thing we've sort of zeroed in on is that there isn't at the moment a focus specifically on this, let's say at the federal or the provincial level, and sort of falls into that area where it's not quite this and it's not quite that. I think that political focus has to exist. I think that's something that needs to be, I'm not sure how, but I think that if there were a political focus that had some well-defined goals, number one, we want to do this. Number two, we want to do that. And it's very clear. That kind of thing would really obviously focus the financial effort, but also just put people on the same footing. So we're not sort of scrambling to try and fit into different niches that ultimately are only overlap partially.
That's super helpful and a great place to end on. Additionally, we'd like to thank the both of you because we wanted the transit perspective and then the innovator perspective on this. We've just opened up the discussion, and of course, we're going to keep pushing it forward. And our goal really is to get to a place where we have a kind of pilot program, a pilot project funded by the federal government, possibly co-funded by the province, with a couple transit agency partners and a rail partner, whether that's Metrolinx or VIA, in order to build out what an optimal data transfer mechanism could look like, at least at a feasibility level for transit scheduling. So that's where we're going to be angling to get to so that we could start initiating this with real studies in the same way, Maureen, that you presented your expansion of network. And even though it's not happening all tomorrow, it really has sparked the innovative thinking about how great the transit service could be in Hamilton, and that kind of empirical evidence spurring the innovative thinking, not only municipally, but regionally and provincially as well. So with that, thank you to Maureen Cousin-Heath at Hamilton Street Rail, and thank you to David Beach at Thales. We'll just go to the final slide here. If you can move forward, Mahnur, one slide, just to inform everybody that the next session coming up as we continue to explore the core themes that we hope will lead to demonstrator and feasibility projects in Canada with CUTRIC and its members is autonomous bus crossings with autonomous rail. I am a firm believer in CUTRIC, firmly believes that a slight autonomy of the buses, and by that we mean SAE level 4, at least at charging stations, is critical for optimal charging of overhead charge buses. But as we move forward, planning for the autonomous bus crossing with rail as autonomous rail, already exists. It's certainly being pushed forward in Europe by the Shift to Rail network. And we will eventually get to a day where we have autonomous bus crossings with autonomous rail, even if it's driver controlled for the rest. And the intention there is looking at how much we can avoid collision between bus and rail through the addition of safety and mission critical autonomy mechanisms. So that's coming up on July 10th, and we welcome everybody back there. If you're not getting our communications for any reason, please flag to my colleague Yawin Lau, who is on the line here today, because we do know as a flag to many of our participants, sometimes our emails do go into your spam boxes if they come through our client management software. So take a look there so that you're not left out in the dark without the information about the next sessions. Thanks very much. Yawin has put the information there. And with that, I will adjourn the meeting at 2:30 p.m. Eastern Time. Thank you once again to Maureen and David Beach, and thank you to all of our participants. Have a wonderful day, and we look forward to seeing you again soon. Take care, everyone.